6 terabytes a month to S3, every gigabyte crossing a NAT gateway at 4.5 cents, $300 quietly every month. Then someone spent 5 minutes in the console, and that same traffic dropped to 0. The destination never changed. Only the path did. Quick hello from Stack Lessons. Now back to it. By the end of this video, you'll know exactly which VPC endpoint to reach for from a scenario, and why one type is free while the other quietly bills you by the hour. This sits in both the secure architectures and cost-optimized architectures domains, because choosing an endpoint is a security decision and a cost decision at the same time. Quick refresher from the VPC Foundations episode. A private subnet has no route to the internet gateway, so it can't reach the public internet on its own. Its only outbound path runs through a NAT gateway sitting in a public subnet. That NAT gateway is fully managed and scales for you. But here's the catch we're building on today. Every single gigabyte that passes through it is metered. Before we get into the mechanics, 5 terms will come up repeatedly. A gateway endpoint is the free route table-based path to S3 and DynamoDB. Nothing to install, just a route entry. An interface endpoint is different. It drops an actual network interface with a private IP directly into your subnet, covering most other Amazon Web Services at a per hour, per gigabyte cost. Amazon Web Services PrivateLink is the underlying technology that makes those interface endpoints work. A prefix list is a managed set of IP ranges for a given service in a region. You point a route at the prefix list instead of tracking individual addresses yourself. And an endpoint policy is the resource policy attached directly to the endpoint, controlling which principals and actions can reach through it. So here's Megacorp's situation. Their procurement servers sit in private subnets, and they constantly need to read and write to S3 and DynamoDB. Right now, that traffic takes the long way around, out through the NAT gateway at 4.5 cents per gigabyte. But think about where S3 actually lives. It's on the Amazon Web Services network already. Sending that traffic out through NAT is paying a toll to reach a warehouse that's on Amazon Web Services property the whole time. VPC Endpoints fix that by giving you a private path straight to the service. No internet trip required. Here's the rule that decides everything else in this video. Ask 2 scenarios. First, is the target S3 or DynamoDB? Second, is the traffic originating inside the VPC that owns the endpoint in the same region? When both answers are yes, you use a gateway endpoint and it's free. If either answer is no, including traffic coming from a peered VPC, from on-premises, or through a transit gateway, you use an interface endpoint and you pay for it. That last part catches people off guard. Even a same region peered VPC cannot use a gateway endpoint. The gateway only serves traffic that starts inside its own VPC. Let's walk that decision as a tree. At the top, ask whether the target is S3 or DynamoDB. If the answer is no, follow the path straight to an interface endpoint. If the answer is yes, drop down to the second question and ask whether the access is same region and same VPC. If that answer is also yes, you land on the gateway endpoint and it costs nothing. But if it's no, you're back on the interface endpoint path, powered by PrivateLink and Build. Notice there's only one route to the free gateway endpoint, and it needs both yeses. So how does a gateway endpoint actually work? When you create one, Amazon Web Services injects a route into the route tables you select. That route doesn't point at a normal address block. It points at a prefix list, which is a set of the service's regional IP ranges that Amazon Web Services keeps current for you. Because that prefix list is more specific than your default route, longest prefix match kicks in and sends S3 and DynamoDB traffic to the endpoint instead of the NAT gateway. And that's the whole thing. There's no network interface, nothing to size or patch. It's just a smarter route in your table. Picture a gateway endpoint as a city subway line. It runs only within city limits, meaning the same region and the same VPC. It's free for residents, so no fares. And once you add it to the map, which is your route table, every station starts using it automatically without anyone reconfiguring their commute. That last part matters. You add one route, and every subnet you selected quietly starts taking the free path. Look at the route table before and after. Before, you've got your local route and a default route to the NAT Gateway. All the S3 traffic falls through to that default route and pays NAT charges. After you add the gateway endpoint, a new line appears pointing the S3 prefix list at the endpoint. Now, because that prefix list is more specific than the default route, S3 traffic matches it first and bypasses NAT entirely. Notice the default route is still there. Everything else, like general internet traffic, still flows through NAT as before. The Amazon Web Services documentation could not be blunter about the cost. It says, quote, "There is no additional charge for using gateway endpoints. That's it. No hourly fee, no per gigabyte charge, nothing hidden." This is why a gateway endpoint is the default best practice for private S3 and DynamoDB access, and why replacing NAT traffic with it is often the single biggest quick win in a VPC cost. Review. Now, here's the part that catches people. A gateway endpoint has hard limits, and they're not settings you can flip. First, it can't cross regions. That prefix list only covers the service in this region, so a bucket in another region simply doesn't match and falls through to NAT. Second, it can't be reached from on-premises over Direct Connect or VPN, because that traffic enters through the virtual private gateway, which ignores your endpoint routes. Third, it doesn't serve peered VPCs or transit gateway spokes. The reason underneath all three is the same. The route table is only evaluated for traffic that's born inside the VPC that owns the endpoint. Traffic arriving from somewhere else never sees that route. Amazon Web Services spells this out directly in the DynamoDB endpoint docs. Quote, "Gateway endpoints do not allow access from on-premises networks, from peered VPCs in other regions, or through a transit gateway. For those scenarios, you must use an interface endpoint." That sentence is essentially a list of wrong answers waiting for you in a scenario. When you see any of those three phrases, the gateway endpoint is off the table. And separately, the docs confirm the same restriction for same region VPC peering connections. Resources on the other side of the peering connection in your VPC also cannot use a gateway endpoint. Here's the technical boundary to internalize. A gateway endpoint route is only evaluated for traffic originating inside its own VPC. That means cross-region access, on-premises connections over Direct Connect or VPN, and VPCs that are peered with this one reaching S3 or DynamoDB all fall outside what a gateway endpoint can handle. In every one of those cases, an interface endpoint is the correct choice. Let's consolidate before we move on. A gateway endpoint is free, route-based, and works only for S3 and DynamoDB. It handles same region, same VPC traffic, and nothing beyond that. It can't cross regions, can't reach on-premises, and can't serve peered VPCs. So for anything that lives outside those bounds, we need the second endpoint type, and that's where PrivateLink comes in. An interface endpoint works completely differently. Instead of a route, PrivateLink drops an actual network interface with a private IP right into your subnet. Then private DNS does the clever part. It maps the service normal public hostname to that private IP, so your application code doesn't change at all. When it calls the service, the request resolves to the local interface and reaches the service without ever touching the internet. And this covers over 100 Amazon Web Services like SQS, Secrets Manager, and the EC2 API, plus third-party software as a service, and even your own services. Think of an interface endpoint as a private phone extension installed inside your office. That extension is the network interface sitting in your subnet. When you dial Secrets Manager or SQS, the call routes through your own internal switchboard, never down a public phone line. You pay a small monthly rental for the extension and a little per call charge, but in return you get a direct private line to almost any Amazon Web Services service. Let's trace the path visually. On the left is your VPC with an EC2 instance and a private subnet. That instance sends its request to the endpoint network interface, which holds a private IP from your subnet's own range, here 10.0.1.42. From there, PrivateLink carries the traffic privately to the target service, whether that's SQS, Secrets Manager, the EC2 API, or dozens of others. At no point does that traffic step out onto the public internet. It's a private line the whole way. Here's the side-by-side you want burned into memory. A gateway endpoint covers only S3 and DynamoDB, works through the route table with no network interface, and is completely free. But it's locked to same region, same VPC traffic, and you can't attach a security group to it. The interface endpoint is the opposite trade. It reaches over 100 services plus outside software. It lives as a network interface with a private IP, and it costs a penny per hour per zone, plus a penny per gigabyte. In exchange, it works from on-premises, and as of late 2024, Amazon Web Services PrivateLink natively supports cross-region connectivity. You no longer need to deploy a separate endpoint in each target region. Though cross-region PrivateLink does carry additional cross-region data transfer charges on top of the standard per gigabyte rate. You can also attach security groups to interface endpoints for an extra layer of control. Now look at the data processing costs for reaching Amazon Web Services services side by side. These figures are for US regions. Rates vary elsewhere. Routing through the NAT Gateway costs 4.5 cents per gigabyte. Send the same traffic through an interface endpoint, and it drops to 1 cent per gigabyte. That's the first tier rate up to a petabyte per month, after which the per gigabyte price steps down further, and a gateway endpoint costs 0. So for intra-Amazon Web Services service traffic, an interface endpoint is already more than 4 times cheaper than NAT, and a gateway endpoint removes the data processing charge entirely. This is exactly why endpoints show up as much in cost optimization scenarios as in security ones. You don't have to take a blog's word for it either. Amazon Web Services' own prescriptive guidance says, quote, interface endpoints incur an hourly charge and a per gigabyte data processing charge. These charges are lower than the equivalent charges for routing traffic through Amazon Web Services' NAT Gateway. So even the paid endpoint type is officially the cheaper way to reach Amazon Web Services services compared to NAT. There is one catch with interface endpoints worth flagging. That hourly charge applies whether or not any traffic flows. You pay a penny per zone per hour just to keep the interface alive. Spread that across a 3-zone VPC, and each endpoint carries roughly $22 a month in baseline fees before a single byte moves. To see if an interface endpoint is worth it over NAT, compare the per gigabyte rates. NAT charges 4.5 cents per gigabyte, while interface endpoints charge 1 cent per gigabyte. That difference is 3.5 cents per gigabyte, so the $22 monthly floor breaks even at around 630 gigabytes. Below that volume, NAT might actually be cheaper. Gateway endpoints have no such floor. They're simply free, always. Now let's talk about controlling what an endpoint can reach, because there's a real security angle here. An endpoint policy is a resource policy attached to the endpoint itself. And here's the thing most people miss. The default policy is wide open. It allows all principals, all actions, all resources. So out of the box, a single S3 gateway endpoint can reach any bucket in any account. The fix is to restrict the resource element to only your own bucket names. Do that, and you've built a control that blocks data exfiltration even when a compromised instance's IAM role has broad S3 permissions. Here's that pattern in action. A compromised instance tries to copy sensitive data out to an attacker's external bucket. The command fails with access denied, and the reason is the VPC endpoint policy. Now, here's the important detail. That instance's role had broad S3 permissions. Under normal IAM rules, the copy would have succeeded, but the endpoint policy only listed the company's own buckets as allowed resources, so the request to an outside bucket never made it through the endpoint. The exfiltration attempt hit a wall the attacker couldn't root around. One more thing to be precise about. An endpoint policy does not replace your IAM policies or your bucket policies. Amazon Web Services states plainly that it doesn't override or replace identity-based or resource-based policies. It's an additional layer stacked on top. A request has to pass the IAM policy, the resource policy, and the endpoint policy. So think of the endpoint policy as a network-level gate that sits alongside your existing controls, not instead of them. Let's carry the essentials forward. If it's S3 or DynamoDB in same region, reach for a gateway endpoint. It's free and root-based. Anything else, or any cross-region, on-premises, or peered access, means an interface endpoint over PrivateLink, and you pay for it. Anchor the cost numbers: NAT at 4.5 cents per gigabyte, interface at 1 cent, gateway at 0. And lock down your endpoint policies to your own resources so a compromised instance can't ship data out. That cost comparison comes back when we get to the cost networking video, so it's worth holding on to. Now let's see how well all of this stuck with a quick 5-question quiz. Question 1. EC2 instances in a private subnet need to read and write objects in an S3 bucket in the same region, with no internet traffic and the lowest possible cost. Which solution fits best? Option A, create an S3 gateway endpoint and associate it with the subnet's root table. Option B, create an S3 interface endpoint powered by PrivateLink. Option C, route the traffic through a NAT gateway in a public subnet. Or option D, attach an internet gateway and give the instances public IPs. Run the 2-part decision rule before you answer. The right call here is A. It's S3 and it's same region, so both parts of the rule say gateway endpoint. That gives you a free, private, root-based path and removes the NAT data processing charge. The interface endpoint in option B would also stay private, but it bills per hour and per gigabyte, so it's not the cheapest. Question 2. An on-premises data center connected via Direct Connect must write records to a DynamoDB table using private connectivity only. A colleague proposes a DynamoDB gateway endpoint. What's the problem? Option A, gateway endpoints support DynamoDB but not from a private subnet. Option B, gateway endpoints require a NAT gateway to function. Option C, gateway endpoints cannot be reached from on-premises networks, so an interface endpoint is required. Or option D, gateway endpoints only work with S3, never DynamoDB. Lock in your answer before I give it away. It has to be C, and here's why. A gateway endpoint injects its root only into VPC root tables, and those tables are only evaluated for traffic born inside the VPC. Traffic coming from on-premises over Direct Connect enters through the virtual private gateway and never sees that root. For on-premises access, you need an interface endpoint. And note, gateway endpoints do support DynamoDB, so option D is just wrong. Question 3. A private subnet application needs to call Amazon Web Services Secrets Manager and SQS without internet access. Which endpoint type is required and why? Option A, a gateway endpoint, because it's free for all Amazon Web Services services. Option B, a NAT Gateway, because Secrets Manager isn't endpoint eligible. Option C, a VPC peering connection to the Amazon Web Services VPC. Or option D, an interface endpoint, because gateway endpoints only cover S3 and DynamoDB. Think about which constraint matters most here. If you said D, well done. Gateway endpoints only ever cover S3 and DynamoDB. Secrets Manager and SQS are two of the 100+ services you reach with an interface endpoint over PrivateLink. Option A is wrong because gateway endpoints don't cover those services at all, and there's nothing free about reaching them privately here. Question 4. A compromised EC2 instance with broad S3 permissions is trying to copy data to an S3 bucket owned by an attacker. Which control most directly prevents this exfiltration through the VPC endpoint? Option A, an endpoint policy restricting the resource element to only company-owned bucket names. Option B, enabling default encryption on all company buckets. Option C, attaching a more permissive IAM policy to the instance role. Or option D, increasing the NAT gateway bandwidth limit. Pause here if you want more time. The answer is A. The endpoint policy is a network-level gate evaluated on top of IAM. When you restrict its resource element to only your own buckets, a write to an outside bucket fails at the endpoint, even though the role's IAM permissions would otherwise allow it. Encryption in option B protects data at rest, but does nothing to stop the copy, and a more permissive policy in option C makes the problem worse. Question 5. A VPC spans 3 availability zones. A team deploys an interface endpoint for a rarely used service that moves only about 50 gigabytes a month. What's the cost concern they should weigh? Option A, data processing charges will exceed those of a gateway endpoint. Option B, the endpoint bills roughly $22 a month in hourly fees regardless of traffic, which may exceed the NAT cost at that low volume. Option C, interface endpoints charge extra for cross-zone data transfer. Or option D, the endpoint requires a separate NAT gateway per zone to function. Got your pick? Let's see. This one is B. Interface endpoints bill about a penny per zone per hour, whether or not traffic flows, and across 3 zones, that's roughly $22 a month before any data moves. As we covered in the cost scene, the per gigabyte difference between NAT and an interface endpoint is 3.5 cents, which puts the break-even at around 630 gigabytes a month. At very low traffic volumes like this scenario describes, NAT may actually be cheaper. Option C is incorrect. Cross-zone transfer is not an added charge for interface endpoints. Done with private connectivity, VPC endpoints, and PrivateLink. Quick ask. Subscribe so you don't miss the rest of the Cloud Architect path. It also signals YouTube to share these wider. Then tell me in the comments what landed and what didn't. Got an exam on your radar I should cover next? Suggest it below. And if you change anything about the style or speed, say so. That shapes the next batch. See you in the next one.